Hi everyone, Mr. Lee, and we're still talking about position time graphs and velocity time graphs. We got position time graph at the top and a velocity time graph at the bottom, but this time, instead of using a cart with the Sonic Ranger, we're going to use a pendulum with the Sonic Ranger. And what I'm going to do is I'm simply going to pull this back and let it go. And we're going to predict first what the position time graph is going to look like, and then try to think about what the velocity time graph is going to look like. Okay? Mr. Bryant's going to hit the activation button to start the Sonic Ranger. Okay? Anytime you're ready, Mr. Bryant.
I like your phrasing, Mr. Lee. I like activating the
Okay,
Sonic Ranger.
ready?
Yes. Here we go. 1, 2, 3.
Oh, that's a nice graph. I like that.
So those look the same.
Oh, but they're not, Mr. Bryant. They're not.
Oh.
Because if you look at this, at this point here, the positioning time graph is flat. So if position time graph is flat, that means it's pretty much staying in the same location. That means its velocity's like not moving. It's very still. So, but if you look right down, see here the velocity is 0. And again, same thing. It's flat here, velocity 0. And it still matches up over here. See where it comes to a flat spot and the velocity 0. Okay? And so the graphs are very similar, but they actually show two different sets of data. All right, thank you.